Alright, welcome to section 2.3. We're still in the chapter Linear Equations and Inequalities One Variable. We'll get to the inequalities at the end of the chapter. We're going to focus right now on the equations for the first 5 sections. And this third section here, the book is adding more terms, adding grouping symbols, parentheses, etc. But because of the way we've structured it for our class together, our notes, the goals and steps from 2.1 and 2.2 all stay the same here. Okay, so we're still on the same track as we were before. And what is that goal? For some of you, you may want to see if you can fill this in on your own now from memory or put it in your own words. For those of you that are just jumping in because 2.3 you needed some video support details, you'll want to use these as your notes. So whatever works for you. You can pause the video, try to fill it on your own, or go ahead and just follow along with me here. The goal remains the same. It's always to isolate x. Get x by itself, or the variable, on one side, all by itself. Then you're going to simplify, and simplify has two things that we're looking for. One is to remove parentheses or grouping symbols. Sometimes we'll need to use distributions. Sometimes we'll just need to use multiplication, or just realize that the parentheses are holding a number in place, highlighting a negative or something. But whatever you need to do to remove parentheses on both sides of the equal signs. We're also going to look to combine any like terms. Again, this is focusing on either side of the equal sign. Then we pick a side, and it's you decide which side. Okay, left side or right side for the variable. Okay, the variable needs to be on one side of the equation, left or right, it doesn't matter. You can pick if you're more comfortable with one side, or if you want to avoid negatives, whatever you want to do, but you get to pick. And how do you get there? Well, you use opposite operations. You use the opposite of what's in front of the variable. Okay. And what we've done so far in steps 1 and 2 are to basically do whatever we need to do to rearrange back to the ax plus b equals c format. And then we'll move on to the solving portion of the steps, and that's where you ask what's happening to x, so that we can see how to undo that. And we'll use order of operations to answer that question. If we put something in for x, what's going to happen to it according to order of operations? We make that list, either a verbal list or a visual timeline, whatever is most helpful for you. And then you're going to undo that list, and that requires two things. You go in reverse order. So up the list, if you made a verbal checklist of 1, 2, 3, you go in reverse order, start at the bottom, work your way back to the top. If you made a visual timeline from left to right, you'll go right to left. That would be the reverse. And you use the opposite operations. And then whatever you do to one side, you do to the other. So whatever you do it to both sides of the equation. Okay. And so step 3 and 4 then are your actual solving of the equation. And many of you will get to the point where you can do a lot of this thinking process in your head, where these steps are to help you get to the point where you can look at the problem and not wonder what you need to do first. You don't question, you don't have to hesitate. You've practiced the steps so many times that you just dive in and start solving the equation or simplifying, that kind of thing, whatever you need to do based on what you see. If you look at an equation and go, I'm not sure how to start, then you need to take it step by step and trust the process of these steps until you can get to where there's no hesitation and you know exactly what to do and you're confident and you're getting right answers every time consistently. Okay? Our final step is to check, and of course we've been emphasizing that that's in the original equation, okay, or back in the original story problem, depending on the situation. So let's do number 6 together, and then the second video will have number 14 on the bottom, and the tries come on the next page, on page 2 of the notes. Okay, let's read number 6. 3x plus 2 minus x equals 6 plus 3x minus 8. As we start 2.3, the question we want to ask ourselves is, what's different about these ones than the one we've been doing? If the steps are the same, how are they making these more challenging? What's next here? And we mentioned it, they're adding more terms, there's going to be grouping and parentheses involved, but we've been rehearsing for that. We aren't going to change our method. We have been ready for this all along. So our first step is to look to see if there's any parentheses we would need to remove, and in this case there's not. So we've checked for parentheses, it's already done for us. Then we look to combine any like terms, and that we do need to do. So in this case, on the left side, you just do one side at a time here. On the left side, I've got a 3x and a minus 1x, or you can think of that of plus a negative 1x, whatever makes more sense to you. So 3 minus 1 is going to give you a 2x, and then you're going to still just have the plus 2. Equal to, on this side, there's only the 3x, so that's going to stay just the way you see it, the 3x. There's a plus in front, so it's positive. We just leave the understood plus. Nope, don't have to write it. But like terms, the constants stick together here. So you've got 6 minus 8, or 6 plus a negative 8, however you want to think about that. What you end up with is plus a negative 2, or just minus 2. However you want to think about that. Again, at this point, we're assuming that you're starting to get comfortable with positives and negatives. If you need more help, please get the help that you need on that. Okay, so now we've taken care of like terms. Our next thing is to pick a side. X needs to be on one side or the other. I'm going to go ahead and move things to the left, face my fears a little bit about negatives here, and just keep everything on the left-hand side. So I'm going to pick left today, and that means I'm going to move everything from the right-hand side. So I look to see what's in front of the variable, not behind it, but in front. There's a understood positive, it's not written. We do the opposite of that, so we subtract the 3x from both sides. What we do to one side, we do to the other. That's the critical rule for solving equations. And then 2 minus 3 becomes a negative 1x, or just negative x, whichever way it makes more sense to you. The plus 2 just comes straight down. The equals come straight down. The 3x minus 3x, they cancel. That was the whole point of doing this. We're moving things away from there. And the minus 2 just comes straight down. Notice that negative belongs to that 2. It's as if we had the plus negative 2 there. That becomes a negative 2 now. You're not thinking that as minus 2 anymore. And then it asks, then we go through, okay, so now we've picked a side. Now we start asking what's happening to x. We're in this ax plus b equals c form here. Negative x plus 2 equals negative 2. So we ask ourselves what's happening to x, and in this case, if you put a number in for x, what would happen? Ignore the side that doesn't have x. Just look on the side that has x. If we put in a number instead of x, what would the first thing you'd have to do? Order of operations say you'd multiply, then you'd add. So we're going to multiply by negative 1. And the second step we would do would be to add 2. Or for you more visual types, you could do it as a timeline. X times negative 1 plus 2. And you would read that left to right. From there, we're going to reverse that to be able to undo what's happening to x and get x all by itself and thus solve the equation. So we do the reverse order, opposite operations. I'm going to go up the list so that my second and final step now becomes my first step. My first step now becomes my last step. Add becomes subtract, multiply becomes divide because we do reverse order and the opposite operation. In terms of the timeline, we'll go right to left here. So the first thing we see is a plus 2, we're going to subtract 2. The next thing we see is times a negative 1, we're going to divide by negative 1. Notice the signs stay with the number, it's the operation that changes. And so now we do exactly what it says to do. I've got, let me write my original equation here. I've got negative 1x plus 2 equals negative 2. Or you could think of that as just plain negative x plus 2 equals negative 2. Okay, and I'm going to start by following my list. I've made a prescription for myself, now we follow it. Either right to left on the timeline or up the reverse list here. First step, subtract 2, or coming from the right, subtract 2. What I do to one side, I do to the other side. And that leaves me with negative 1x. The 2's cancel. That was the whole point. We're getting rid of everything that's happening to x on this side by stripping it away in reverse order here. Negative 2 minus 2 is the same as negative 2 plus a negative 2, so same signs. That gives you a negative 4. Then, so I've done that part of the checklist here. My second step would be divide by negative 1. As you continue to the left here, yep, divide by negative 1. So I'm going to divide both sides by negative 1. Fraction is the same as division. Very important concept here. And the whole point is the negative 1's cancel, because you've got negative 1 divided by negative 1, which is just a positive 1, or just plain x. Negative 4 divided by negative 1, negative divided by negative is a positive 4. So our x is 4, and now we get to check it. I go back to the original. You can do this in your head if you're getting good at that mental math here. Always back to the original. And I'm just going to take my answer here and plug it in every time. This is the way I do it. Sometimes I get brave enough to do it in my head, but not during notes, because I'm trying to demonstrate what's happening in my head for you on the paper. So I put a 4 in each of those times, and I'm just checking. So I give myself a little question mark here. 3 times 4 is 12, plus 2 minus 4. Does that equal 6 plus 3 times 4 is 12? Minus 8, and I go left to right here, and I get 12 plus 2 is 14. Let's make sure I'm still on screen here. Oh, that's close. Let me adjust just a little bit. Sorry about that. Continuing on with the check, 12 plus 2 is 14. Minus 4, does that equal 6 plus 12 is 18. Minus 8. That gives me 14 minus 4 is 10, 18 minus 8 is 10. That is a true statement. My answer checks. I'm ready to put it in set notation. Little French, they're not really French, braces. The answer is 4. Okay, we'll go to the bottom of the page in the next video. See you there.